Hi, welcome to my session on financial modeling. So this is my first session, which I'm going to talk about financial modeling. If you want to know the basic of MS Excel, right now I'm using MS Excel 2013. You want to know more about MS Excel, about 2013, how 2013 is different from 2007 and 10. You can refer my videos on basic of MS Excel. This is about financial modeling. This is the first session on financial modeling, and in this session I'm going to talk about the topics like talk about time value of money. I'm going to talk about time value of money. In time value of money, we'll do the financial formulas related to FB, PV, PMT. We'll talk about NPV, IRR. We're going to talk about XNPV, then XIRR. Fine, and we're gonna talk about loan amortization schedule. Loan amortization schedule, where we'll talk about the formulas like PPMT. We'll talk about IPMT. We'll use these formulas. We use IPMT. We take the application of goal seek, and we'll do data table in this session. So this session, I'm going to talk about the advanced financial, basically advanced financial Excel. I'm going to talk about where this is the one of the part of financial modeling where we're going to talk about time value of money. We're going to talk about loan amortization schedule. So let's talk about the time value of money where we can use the principle of compounding. So I hope you know about compound interest very well. So compound interest derive its concept from simple interest. So when we talk about compound interest, the basic formula of compound interest is FB is equal to PV into 1 plus rate of interest to the power n. This is the formula of compound interest. More or less, we use a formula like amount is equal to principal into 1 plus r percent to power n. So here instead of amount I can write FB. FB means future value of money, PV means present value of money, R is your rate of interest, so which your value of money is multiplying, and N is the time period. So when I talk about compound interest works on the concept of interest on interest. Interest on interest. So credit card company, if they're charging 2% per month on the amount which you have outstanding, that will never become 24% per annum. That will always be more than 24% because of the effect of compound interest, interest on interest. So that we're going to talk about, we're going to talk about the compound interest in that context where the amount of every n year become the principal for next year. So imagine a very simple example I'll take. Suppose there's a person called Mohan, and this guy Mohan, he deposited 1,000 rupees in a bank. He went to bank and he deposited suppose 1,000 rupees, and this money he withdraw after 4 years. Suppose he withdraw this money after 4 years, and the bank, normally all nationalized bank more or less gives an interest rate of 4%. So the rate of interest what the Mohan got on his deposit, he got on a deposit a rate of interest of 4% per annum. So 4% per annum means the bank is charging interest rate of 4% per annum. So ultimately the future value of money what the Mohan get at the end of 4 years, that would be 1,000. That would be 1,000 into 1 plus 4%. You can write 4% to the power 4, and Mohan got about 1169.859 rupees after 4 years. Fine. So instead of writing like this, what you can do the same calculation where instead of writing the figures manually, you just go to the cell where 1,000 means C10, where C is the column and 10 is the row, into shift 8 into 1 plus R percent. So the R percent, this R is in C12. So you can know the address of the cell, you can use a mouse, then shift 6 for the power, and then for the year you can click on C11 and you'll get the same value. So the advantage, what advantage you'll get if you use a formula instead of writing the data manually, if you change the figure, imagine instead of 1,000 rupees Mohan would have deposited 1,200 rupees, then you would have got 14.1403 rupees. Instead of 4 years, if you have deposited the money for 5 years, you would have got 1459.983. So it's better, I always suggest you that you always try to use the basic parameter, where you can try to use the formulas, try to use the cell references instead of writing the values by yourself. So you'll understand the implication of this. So imagine you did some calculation here. This calculation you don't require, you know how to remove the formula. Already I discussed all this thing in my basic uh, MS Excel session. You can copy this and Alt ESV, you can use a shortcut key Alt ESV, or you can go to paste, and in paste you click on value, so formula will get removed. In here, if I write 1500, any figure I write, this figure will not change. So you are well versed with this concept. So future value of money like this you can convert by using this formula. What is your present value into 1 plus your rate of interest to the power year, and you get this much money as a future value. So the why you got this figure 703, you can explain it mathematically. You can write 0 to 1, then suppose 1 to 2. I can show you mathematically. Then suppose 2 to 3, then suppose 3 to 4. Imagine for the 4 years I deposited this money. Imagine for the 4 year I deposited this money, and copy this data. Now same data I want vertical, so this is horizontal. To transpose this, go to paste, and you can go to paste spatial transpose. Otherwise the shortcut key is Alt ESC, you get the same thing. Now your principal was 1400. On 1400 your rate of interest was 4%. 4% was your rate of interest, so you got 56 rupees as the rate of interest. So at the end of first year you got 56, then at the end of second year, sorry, you got 56. Copy this, you got 56, then every year you got 56, then fourth year you got 56. 56 is the interest what you are getting, but this is compound interest. In the case of compound interest, you get interest on interest. So the 56, which was a principal, uh, beginning, on this 56 with the interest what you get. So next year again you get interest on of 4% on that. So this 56 will not be 56 at the end of second year. On this 56 you get an interest of 56, so 56 into, you get interest of 4%, so you can click on that, so you get 58.24. the same thing, 58.24, on that you got interest of 4%, so you can write as 1.04. then on this you get an interest of 4%, 1.04, you get 62 points. So like this, if you calculate, you can get the value on interest, and this will become 58.24. So if you calculate at the end of 4 year what money this guy Mohan would have got, so he get a total of 237.802. so if your principal is 1400, so on 1400 if you add 237.802, you get 161637.802. This is, I'm talking about 4 years, you change it 4 year, so you get 1637.802. So this is the way you should calculate. This is the logic behind the mechanism of how the logic of compounding works. This is the game of compounding. This is the game of compounding, the logic of compounding. So after certain period of time in future, you're not going to remember these formulas of time value of money. So what you can do, the same thing you can do in Excel. The same thing you can do in Excel. Write FB, open bracket, then see what Excel is asking. Excel is asking the rate. So in rate, click 4%, comma NPR. NPR means the time period. In time period, click 4, then comma PV. PV means present value of money. Here the bracket is a bracket, means negative sign. So put negative sign on this PV. Type means type can be 0, it can be 1. 0 means annuity, 1 means annuity due. If you do not write, also not a problem. Otherwise just click write 0, enter, write 0, enter. What value you get? Let me do it again. FB, rate was 4%, NPR was 4 year. PMT put 0. PMT, sorry, I've not seen the PMT. PMT put 0. PV put the present value of money 1400, and type put 0. Type means 0 means annuity and 1 means annuity due. Where what is PMT means? PMT means the case of if annuity is there, we call annuity here as PMT. Here there's nothing called annuity. You just one time you deposited this 1400 rupees, so there's no concept of annuity here. The present value is 1400. Type is 0. Close bracket, enter. You get 1637.80. So this way you can calculate the future value of money. Now I'll talk about the present value of calculation. Now suppose after 7 year, I will receive rupees 1800 from Siam. Suppose after 7 year I'll receive 1800 from Siam. After 7 year I receive 1800 from Siam, and the inflation rate in the market, the factor का inflation which reduce the value of money. Inflation rate in the market is suppose 8.5% per annum. Fine. So what is the present value of money what I'm going to get from Siam? So for the present value of money, you can calculate the present value is equal to future value divided by 1 plus rate of interest to the power n. So you can, by this you can determine the present value. So present value of the money, if you want to determine, for that, write present value is equal to future value is 1800 divided by 1 plus r percent is 8.5%, and to the power 7 year. After 7 year, because shift 6 7, if you do, you'll get the present value of money like this. Fine. So better you do in the term of formula. Your future value is 1800. Your rate of interest is 8.5% per annum. Your rate of interest is 8.5% per annum. Your time period of your investment is probably 7 year. Fine. So your present value of your value of money would be 1016.867, that you can determine as 1800 bracket open 1 plus 8.5% shift 6 7. If you do, you get the same value 1016.867. The same thing you can calculate in Excel by using PV formula. PV bracket open, rate is 8.5%, NPR would be 7 year. PMT, there's nothing called PMT, one time we're talking about depositing or receiving money. Future value, put negative sign, is 1800. Type is 0. Always we use a 0 only. You get 1016.87. So I hope you guys are understanding. Very simple concept. Now in the same question what we studied, in the same question, if I deposit 1400 rupees now, after 4 year it will become 1637.802. Fine. I want to know the time period. Like here the time period is 4 year, so I want to know the time period of my investment. So here I can calculate it manually. Imagine that's not given. Suppose it's not given, when it becomes 4 year. So what you can do, you can calculate this. Let me remove the formula, otherwise the figure will change. So suppose I don't know the time period. Suppose that is X year. I want to know after how many year my 1400 will become 1637 if the money is growing at the rate of 4% per annum. Fine. Suppose this is your question. Where I want to know after how many year my money will become my money of 1400 will become 1637.802 if I deposited the money in a bank where the bank is offering me 4% interest per annum. So for that you can calculate NPER. For that in Excel, if you write NPER means time period. rate is 4%. PMT, there's nothing called PMT here. Present value of money, so present value of money is 1400. In future value, put negative sign because you can see this written, you can see the bracket over the future value. Then type put 0, you get the value 4. So this is a very simple formula. Otherwise, if you want to do manually, you would have done like future value is equal to present value into 1 plus rate of interest to the power n. So if you want to find the value of n, so if the unknown is in power sign, then only way you can do is log of future value divided by present value. This should be divided by the log of 1 plus r%, 1 plus rate of interest. So if you use this formula, you can determine the value of n. So the n here, if I use log, so log of, so you can write future value by present value, future value by the present value. So this would be divided by the log of 1 plus r%. So r% is 4%. You get the value 4. So anyway you do, you get the same answer. So the 4 year. And now suppose if I want to determine the rate of interest, so like the money which I deposited, that money will lead to, see the error came because the formula was there. So you can remove the formula, Control C, use a shortcut key, Alt ESP. Fine. So you can do this and you can get the answer. Now suppose I want to determine the rate of interest. So at what x% rate of interest, at what x% rate of interest, the 1400 will become 1637.802. So if you want to determine the rate of interest, for that use a formula rate. NPR would be 4 year. PMT, here there is no concept of PMT. PV is 1400. FB would be put in the minus sign, 1637. Type would be 0. Guess means you can guess some percentage. You don't write, also not a problem. Suppose I guess 10%. So you can see the answer 4%. You can check the answer by pressing F2. So by that you can get the answer, rate of interest. Very simple calculation. So the same rate of interest in Excel you can calculate by doing manual calculation by using log. So if you use log here, in this case the rate of interest you can determine by the formula called anti-log of, or you can do log of future value or present value divide by 1 divided by 1 by n. So you can do 1 by n rate of interest you want to determine. You can write the rate of interest by using this formula, future value by present value to the power 1 by n minus 1 into 100 So you can use this formula to determine the rate of interest directly if you want to determine. So future value by present value, then to the power 1 by n. N is 4 year. Close this. Now future value by present value can determine, then 1 by n, then minus 1, then minus 1 into 100. You get the 4%. Fine. So anyway you do, you get the same answer. Very simple concept on use of this compound interest logic. Here you can talk about continuous compounding. In this case you can talk about continuous compounding. Continuous compounding is a special case of compound interest. When I talk about continuous compounding, my can talk about continuous compounding. Continuous compounding is a special case of compound interest where when the rate of interest which we use in derivative market, when the rate of interest changes per second, so then the formula of compound interest will become will be then the formula of compound interest when the rate of interest changes every second, then your formula of compound interest would be future value is equal to present value into 1 plus R% divided by 365 into 24 into 3600 to the power 365. In 1 year you have 365 days. In 1 day you have 24 hours. In 1 hour you have 3600 seconds. So n is a time period. So this is the formula what you need to use under such kind of cases whenever you have. Otherwise what you can do, you can go to home. I'll show you. I'll write equation for that. Future value is equal to present value into 1 plus R% divided by 365 into 24 into 3600 into 3600 to the power 365 into 24 into 3600 into n is a time period. So instead of using such a complicated formula, this is the formula of compound interest in the case of continuous compounding where the rate of interest changes every second. So what you can do, instead of using such a complicated formula, you can use this formula called future value is equal to present value into e to the power exponential e to the power Rn. R is your rate of interest, n is the time period. So I'll show you. Imagine your principal. Take this case only. Suppose copy this. Take this case only. So if your rate of interest is suppose 4%, if your rate of interest 4%, if you want to determine the future value, so your future value would be 1400 into 1 plus rate of interest is 4% divided by 365 into 24 into 3600 to the power 365 into 24 into 3600 into n is 4 year. You get 1642.915. The same thing you can do by getting the right FB into e to power Rn. E in Excel is represented by exp. Put open bracket means power 4 into 4%, where the rate of interest changes every second. See this, you get the same answer. Instead of doing such a complicated way, you get the same answer here. This is called continuous compounding. We'll do a lot of application of continuous compounding in MS Excel sheet. You can refer when we'll do about derivatives, when we'll talk about Black-Scholes model, binomial tree model. That time we can talk about this continuous compounding a lot. So my focus would be on the time value of money, more risk, more return. I'm talking about that concept prominently in my session. So you can work on them. Now, possibly when we looked into the scenario where the rate of interest changes on periodical basis, imagine if the year is like this. Suppose 1, 2, you can select 1, 2. Suppose, for example, I deposited the money for 10 years in the bank. Suppose I deposited money for 10 years in the bank, and every year, imagine I deposited around 1000 rupees in the bank. Suppose every year I deposited 1000 rupees in the bank. Suppose every year I deposited around 1000 rupees in the bank, and in the money what I'm depositing in the bank, 1000 rupees, the bank is calculating the interest at the rate of 4% per annum. The bank is calculating the interest at the rate of 4% per annum. So the future value of money, what would the future value of this 10 year, after 10 year, if I go and withdraw the money from the bank, how much money will I get from the bank? If I want to know, where if every year I'm depositing 1000 rupees in the bank and the money is growing at the rate of 4% per annum. So this 1000 rupees which I deposited this year, it will grow for the remaining 9 years. 4% the rate of interest to the power 9 would be 10 minus 1. Fine. Or in 10 you can fix this cell of 10. I hope you know about fixing cells and all by using F4 key. Fix this cell, you get the future value of 1000 rupees for the 9 years. Like this you can do for all other. So the money which I deposit the 10 year will not grow, because like I'm putting and now only I'm withdrawing. This is about the annuity, where this 1000 rupees will be called as annuity, where what is annuity? Where you pay or receive a constant amount of money after every regular interval of time, that is called annuity. So this value, this value, future value of annuity, the future value of annuity, if I want to determine, so that is nothing but that is the sum of them. So the sum of them, if you close bracket enter, you get 12,006 rupees. If every year we deposit 1000 rupees in the bank, so after 10 years it become 12,000 rupees. You can see the advantage of time value of money in this context, how the time value of money is such an important factor. The same thing you can calculate in Excel. Just write FB and rate 4%, NPER 10 year, then PMT minus sign, because here all 1000 rupees, they are the case of annuity. So that is PMT comma PV 0 FB 0, close bracket enter. See this, you got 12,006.11 rupees. Very easy concept of time value of money, how you can understand the relevance of annuity and how annuity is such an important factor for you. The same annuity you can calculate by using the different formulas, and on annuity whatever you have, you can calculate different formulas annuity for them. 1 minute. So that will give you a lot of understanding of how you can work on annuity concept. Now if you use a formula of future value of annuity, if you use a formula of future value of annuity mathematically in book, the formula is, here I'm not able to write properly, we need Word document. A divided by rate of interest, A divided by rate of interest into 1 plus rate of interest to the power n, to the power n. So future value of annuity is minus 1. So this is the formula of future value of annuity. A by R 1 plus R percent to n minus 1. So the future value of annuity, when you work on them, when you work on certain scenario, 1 minute. Fine. So you can determine the future value of annuity. So your annuity was 1,000 rupees every month. What you're putting, rate of interest is 4%. Then shift 8. Then 1 plus rate of interest is 4% to the power 10 year, a divided by r, 1 plus r plus 2 to the power n minus 1 minus 1. Close this. 1 plus r percent to the power n. We get 112,006.11. So this is about the future value of annuity. In case if the future value of annuity due is being asked, so instead of 0 you can just write 1 to get the value of future value of annuity due. Additional 1 point r percent get add on future value of annuity. If you see this was the future value of annuity into 1 plus r percent. So r percent, you can find out the the r percent, the rate of interest 4%, close bracket, enter. So you can see 12,486.35. So the calculation part seems to be easy, and based on the calculation we can work on the scenario. We can determine the future value of money, we can determine the present value of money. Suppose somebody promised me that he'll give me 1,000 rupees every year. Suppose there is someone who promised me that he'll give me 1,000 rupees every year for the next 10 years. So suppose now the 1,000 rupees become the future value of annuity, where somebody promised me that he's gonna give me 1,000 rupees every year. So what you can do, you can talk about present value of annuity. So here in this case, you want to determine the present value of annuity. Imagine these are the future value of money, and you want to determine the present value. You want to determine the present value. Now in order to work on the present value calculation, you can take future value of money divided by 1 plus r percent to the power n. Take this value and take the total sum of them. So the present value of annuity, if you want to determine, now the present value of annuity if you want to determine, so the present value of annuity would be very simple. Write PV, bracket open, rate is 4%. Then NPR means the time period, that is 10 year. Then PMT, PMT would be annuity. Here you have lot of figures of annuity. So here annuity put 1,000, PMT 1,000, then FB would be what is FB? FB would be the total sum of the annuity. So here 1 minute, PMT is only the 1,000. Determining the FB, there's nothing called FB here. PMT is only the 1,000 rupees what you're putting every year. So FB is 0, type is 0, close bracket, enter. So 1 minute, you can do this calculation by doing this formula. PV bracket open, rate is 4%, NPER is 10 year, PMT here would be 1,000, FB would be 0, type would be 0. So this, if you do the sum, so the present value of annuity, if you do the sum, the value of present value of annuity is 811. Fine. So you can determine the present value of annuity, you can determine the future value of annuity based on very simple pattern, based on very simple formula what you have, and that will give you a lot of understanding. Annuity means when we receive or when you pay the constant amount of money after every regular interval of time. That is basically called annuity, and you can work on the annuity calculation in that manner. That give you a lot of understanding of how you can work on annuity. You can determine, you can talk about example of PMT calculation, like suppose I have a dream, I have a dream, I have a dream to have a house, to have a house in Bangalore, to have a 2 BHK 3 BHK house in Bangalore. Fine. So I have dreamed to have a house in Bangalore, but I don't know how the dream will be sustained. What would be the scenario that I should work on so that I can get my dream? So suppose I have a dream to get a house in Bangalore. So I will take very simple example. So uh, suppose if I save, suppose if I save, suppose if I save 8,000 rupees every month. Suppose if I save 8,000 rupees every month. Suppose if I save 8,000 rupees every month. So when suppose I save 8,000 rupees every month and put in a bank and put in an FD offering offering me an interest rate of an interest rate of maybe suppose 4% per annum, maybe the interest rate of 4% per annum. And if I want to buy a 50, suppose 50 lakh rupees house in Bangalore, and I'm thinking to save 8,000 rupees per month, I'm putting in FD which gives me 4% interest every month, 4% very less, FD is there, so 9% interest every month. And my dream is to get a house in Bangalore. So what way can get? And suppose I want to have a dream house in Bangalore, and I'm thinking to save 8,000 rupees per month and put in FD which offers me 9% interest per annum. So this offers me 9% interest per annum. uh, the, if I put the money in FD, whatever money I put in money in FD, and what I'm expecting, I'm expecting that possibly after how many years I can get the house. And my dream is like I want to have a house maybe in 7 year down the line or 5 year down the line. So suppose I have to have a dream to get a house in Bangalore, and if I save 1,000 rupees per month and I put in FD which offers me 9% per annum, you need to find out the way they calculate FD. They calculate the interest either compounding semi-annually or half yearly, quarterly. You have to find out. And although it won't impact much, but yeah, it will impact in the long run. So suppose I put the money in FD which offers me 9% interest per annum. This money if I put in FD, this offers me 9% interest per annum. and 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 I wish to buy house. I wish to buy house, and I wish to buy house after 7 year. After 7 year. So the dream project of me is like, the dream project of me is of right now not very overstated figure. Maybe around 2 crore is my dream project. So depends upon person to person, depends upon the scenario, or the saving, depend upon more risk more return, how much more risky derivative kind of position you take in the market. And so that is the scenario what I'm looking for. And my dream project is to get in house of 50 lakh. I think 50 lakh is a good figure. Of 50 lakh, 1 2 3 4 5. So my dream project is to get a house of 50 lakh rupees. So I can find out is this possible or not, by saving 8,000 rupees every month. Is this possible or not? So the FB what I'm looking for, is 50 lakh. Just assume, just I'm writing some dummy figure, doesn't matter. I'm not thinking only, I'm just writing 50 lakh. So 1 2 1 2 3 4 5 6. So this is the future value of money, and the time period is 7 year. The time period is 7 year. The time period is 7 year, and the rate of interest is 9% per annum. The rate of interest is 9% per annum. This is my dream project, to get a house of 50 lakh rupees in Bangalore after 7 year. And the rate of interest, what the bank is offering, FD, you are getting 9%. So what is the minimum money I should deposit in FD so that I can get my dream project? So for that, you use a formula PMT. The rate is 9%. Then NPR, that is 7 year. Then PV, the PV is 50 lakh. PV is 50 lakh to dream project that you want. The PV put 0, and your dream project is that you want to have a house of 50 lakh, comma 0, close bracket, enter. So it comes around 5,43,452 rupees you have to pay every month. Here, sorry, the small cap, the error happened. 7 year, and this I'm depositing every month, I'm receiving every month, so it will be 84 period, and 9% they calculating the interest every day. So better convert in this manner, and now do PMT. The rate is this, comma, NPR would be 84, comma, the PV would be 0, and FB would be 50 million, and type would be 0, close bracket, enter. Seven year, 9% per annum, 9% per annum, 945, 9% divided by 12, 3 by 4. 3 by 4 means 0.75%, means 0.0075. Fine, you can calculate the formula here in this case. So if you look into the formula, PMT formula, so here in this case, every month you have to deposit 42,000 rupees in a bank, then only you can get your dream house of 50 lakh rupees. So that is something which came around after 7 year. So how much money should you deposit in a bank? Instead of depositing 8,000 rupees per month, better stop dreaming of house of 50 lakh rupees, or maybe start increasing the corpus amount. Every year we need to deposit 9. Every year we need to 42,945. So that creates a problem. And so if in order to get a house of 50 lakh rupees every month, we have to deposit 42,000 rupees. Fine. So like that way here, if you think, if you see this, now if I see this scenario, in this scenario 42,000 rupees every month is very big figure. The if I'm think if I look into this scenario, 42,000 rupees at this moment is very big figure. I cannot think of uh, paying 42,000 rupees every month as an EMI. So that become a complicated. So ultimately this shows that maybe the value of dream house, the price of dream house, I should not think about 50 lakhs, should think of something less, because they're saying that uh, the how much you are earning potential, you should dream also of that much. So the price of house, what should I look for? So that there should be some figure which we try to determine here. Fine. And suppose uh, I wait for another some period and I made a down payment. I said because 42 lakh at 42,000 every month will not make any sense. So suppose I am ready to make a down payment of suppose maybe around 5 lakh rupees. I'm ready to make down payment 1 2 3 4 5. Fine. So now the loan, what I'm gonna take, suppose I want to buy a house, and the thing is that the earlier option what I had, I'm not going with that option because 42,000 rupees per month as an EMI is not at all feasible solution for me. So what I thought of, instead of going with an equity, I can go with a debt mode, and let's borrow some money from the bank. So what should we the price of house, what should I look in the market, so that I can survive by paying 8,000 rupees per month as a EMI, and by paying 50 lakh rupees as a down payment. So for that you can use this formula, price of house minus the down payment. So if you use this formula, price of house minus the down payment, if you use this formula, the price of house minus the down payment, you can, if you want red color, you can go to number, you can click there, they'll show you. So now the loan would be this much figure. Now if you want to calculate the PMT or annuity or EMI, the EMI if you calculate by using PMT formula, so that rate would be 9%, and PER would be 7, then PV is the present value of the loan, would be this figure, FB is 0, type is 0, close bracket, enter. You got this EMI figure, but you ready to pay 8,500 rupees. Go to data, what if analysis, click on goal seek. If you click on goal seek, the goal seek will help you to do this experiment. In set cell, click on the cell which value you want to change. The here, if you look into this scenario, so set cell this, and the EMI I can't pay this much, so I can only pay 8,000, which is my every month saving. Change this figure to this figure by changing which cell, by changing the price of house cell. So if you do this, press OK. So the Excel will calculate everything. In Excel will give you can find the price of house, what you should look for the market. You should look for the house in the market if you can make a down payment of around 5 lakh rupees. So you can look for a house in Bangalore which cost you 5,42,263 rupees, then only you can survive. So whatever would be the price of house, some part of the price you pay in the form of down payment, and on the remaining money only they charge interest on that. So this is the basic framework on how you can work on this kind of situation whenever the such kind of situation is given to you. So I can explain you, here you can see the loan is of 42,263 rupees, and every month you are paying an EMI of 8,000 rupees. So the total payable to the bank, if you think about how much you are paying to the bank, total payable to the bank, if you calculate the total payable to the bank, so that would be the EMI you're paying every month, and this will pay for this will pay the EMI you're paying every month, and this you'll pay for the remaining 84 period, 7 year. So you are paying 6,72,000 rupees, where you're taking a loan of around of 42,000. 1 minute. 5 lakh rupees you made a down payment, so loan you're taking as 40,000 rupees as a down payment. So total payable what you can do for the bank, you're paying to the bank this much, your loan is of this much, so the total interest what you pay to the bank total interest would be the total payable what you are doing minus what was your loan commitment. So that will give you the total interest figure. What is the total interest figure here? So the price of house, if I make a down payment of 5 lakh rupees, and I'm ready to pay an EMI of 8,000 rupees here in this case, so I can calculate my EMI. TMT, if you use this formula, rate of interest, this was your rate of interest, comma NPR, this was your NPER, comma PV was your loan, future value 0, type 0. Fine, so just put some figure here. Now this was your 5 lakh rupees was a down payment, your loan was this minus 5 lakh, and your EMI came around PMT, rate of interest was this much, comma NPR is 84, comma PV is minus present value of loan, type 0. Then what you can do, you can go to data, under data what if analysis, goal seek, set cell, which cell you want to set, this cell, to what value you want to sell, you want to check, you want to put a value of 8,000. By changing which cell, you can pick the price of house, press OK. If you press OK, then you can see this EMI, you are ready to pay 8,000 rupees EMI, and you are paying this for 84 periods. So you total you're paying 6,72,000, and your house should be of 9,97,000, where you made down payment of 5 lakh, 4,97,000 would be your loan, and the total interest what you actually paying to the bank is 1,74,000 rupees. You can analyze the situation, what you have, you can analyze the situation based upon the scenario what you have. You can analyze the situation. How you can analyze the situation, take the figure of year, suppose I took 10 year, 12 year, 13 year, 14 year, 15 year, 16 year, 18 year, 20 year, take the year period, and how much you're paying, this are your years, and here the EMI, you can analyze the situation. Your EMI is 8,000 rupees, your total what you're payable to the bank is 6,72,000 rupees, this much you're paying total, and your total interest came around 1,74,000 rupees. You can prove this figures, like 84 periods are there, so I can prove this figure. You can write periods like this, write one, here, go to home, under home go to fill, under fill go to series, click on column, here click 84, so from 1 to 84 period would have came. Now what you can do, write down your principal. What is your principal? This is your loan amortization schedule. Write down your principal. Your principal would have been whatever loan you're taken, that is your principal. Fine, this is your principal. Your EMI is 8,000. Fix this cell, F4. Now interest is, this is your loan on this, the interest rate is the rate of interest, whatever the rate of interest, this is your rate of interest. fix this. Fine. So extra principal paid, so that would be EMI minus the interest. This is the extra principal what you paid, so because of which the remaining principal left would have been, this was your loan, this is your extra what you paid, so next year this will become the principal. Fine. EMI will always be constant, interest would be calculated on this principal, extra principal would be difference between them, and the remaining would be the difference of the figure. So if you see this figure, at the end of 84 period you get 0. So how much you paid the total interest, you can see the total interest, see this, and total payable, the into this is commas, there's no doubt between that. Like this way you can calculate your figures, whatever the figures comes in there. This is called loan amortization schedule. This is called loan amortization schedule in Excel. This is called loan amortization schedule in Excel. You can calculate like this way. Or interest, when you talk about the calculation of interest, you can calculate the interest by the formula, right? IPMT. And then in rate, what is the rate? Rate is your IPMT. This is your rate. So fix this rate. I don't think fixing would require here. Let's see. Your rate is this, is your rate, comma, then PER. PER would be the first period. It will keep changing. Then what? NP, then NPER. NPER means the last cell. So this is 84. This you need to fix it. So fix the first cell also, rate. Then PV. PV would be minus of whatever is your principal minus PV, that will fix this cell. FB0 type 0, you can see this. So you can calculate your IPMT by using this formula. Your interest or the remaining principal left, what you got, this you can calculate by using PPMT formula. That figure you can calculate by using this PPMT formula. Rate would be the cell. The rate would be the cell. F4. PR is 1. NPR is 84. PV is minus sign. PV is this. PV is this. Then 0, 0. you get the same thing. Remaining 1 minute. We need to fix this cell. Write PPMT rate. The rate, when you write the rate, fix this cell. PER would be 1, comma, and PER is the last cell, 84. Fix this cell. Sorry. Fix this cell. PV, is this is your PV. Fix this cell. 0, comma 0. 4270 remaining principal. Here it's extra principal paid. Sorry, this is extra principal what you paid, 0.76, not the remaining principal paid. You can get this figure 4302. So you can calculate that figure by using this PPMT, and you can calculate interest by using this. So anything you do, you'll get this figure. Now if you add them, you'll get the EMI. Now if you add them, you get the EMI figure. Always it will come 8,000. Fine, very simple concept. You can use this and you can see the practical implication of it. So we can, in Excel, we can use data table. By using data table, we can analyze the situation for this given year, where if I pay 8,000 rupees as an EMI, and the total if I'm paying to the bank 6,72,000 rupees, and my total interest is 1,76,000. So what would the scenario here? I can analyze the situation. Select this cell, go to data, under data, what if analysis, go to data table. Under data table, the value on which I am analyzing is the time period. So row input cell is nothing, column input cell, put the time period like 10, 15, these are all the time period. So you're analyzing this time period, press OK, you'll get the answer. Now you can analyze. If I had taken 13-year loan of 50 lakh rupees, or maybe the 4,97,000 rupees, and then you can think about a scenario. Then what would be a total payable? How much would I have paid? The same thing if you write anything, so data table whole will get changed. So you want to edit it, you want to give proper heading for that. Go to format cell, custom. Under custom, click on general, and under general you can write as EMI, write with double quote EMI. Then this is the total payable, control 1, custom, click on general, this is the total payable, write with double quote. Here control 1, custom, general, then here you can write total interest payable. So by this way you can analyze the situation. Whatever scenario situation come to you, can analyze the situation. This is called one-way data table, and you can see this. If I had taken 10-year loan or 15-year loan or 20-year loan, what would be my EMI, what would be my total payable, what would be my total interest scenario. So this is called one-way data table of analyzing. You are analyzing by using one-way data table. You are analyzing by using something called one-way data table. You can use two-way data table. This is a one-way data table. You can use two-way data table to do better analysis of the given scenario. You can take two-way data table where you take two variable. Suppose one variable is time period. Suppose one variable is time period. So you can copy this time period. And suppose another variable is the loan. If I instead of 4,97,000 loan, if I have taken suppose 4 lakh rupees loan, 1 2 3 4 5 6, if I have taken 4,50,000 rupees loan, 4,50,000, so 1 2 3 4, 4,50,000 here, 4 lakh. How much loan should 1 2 3 4 5? Fine, if I have taken 5 lakh rupees loan, 1 2 3 4 5, then you are taking 6 lakh rupees loan, 1 2 3 4 5. So if for this period, if I taken loan of this much, 4 lakh, 5 lakh, 6 lakh, 7 lakh, then I put the EMI. I want to analyze the EMI. What would have been the EMI under each of the scenario? So what we can do, select the range, select the complete range, go to data table, what if analysis, data table, then row input cell, the row input cell. If you click on the row input cell, in the row wise you have the loan amount. Loan amount means this. Then column input cell, column input cell, column is year, so click on year. You can see this. Okay, control 1, go to custom, go to general, write here double quote, write with double quote, make the cell empty. This function is about using the double quotes. By this way you can make the cell dead. Now if I had taken this much amount loan and for this many year, what would have been my EMI? So you can do very good analysis if you have data table with you, and you can learn one way and two way data table. That is very important. Learning is most important too. Like this, the one way data table is like the same scenario. You have one way data table, you have two way data table, and it help you a lot to analyze like here I've taken example. Like suppose I had a dream to have a house in Bangalore, and I can save around 8,000 rupees every month, and the FD is offering me a 9% interest per annum, and I want to buy a house possibly after 7 years. So you can use the future value of annuity, where you can rate of interest was this, NPR was this, and PMT NPR would have this, rate NPR is this, then PMT. So PMT would have been what? PMT means every month I'm putting 8,000 rupees. That is my PMT. PV is 0, type is 0. So if I'm depositing 8,000 rupees every month in FD, so I can only buy 9%. The interest they're giving 9% interest, so I can buy a house of 9,31,000 after 7 years. Now imagine under this scenario the same thing what I explained by using goal seek. So my dream was to buy, suppose, 13 lakh rupees house. 13 lakh rupees house was my dream. Fine. So my dream was to get a house of 13 lakh rupees, so where all the family can live together. So under that kind of situation, you should know what is your down payment and what is the loan amount. You can pay 100% down payment, or 100% you can take a loan. So depending upon the RBI guideline on the loan and what parameter they use for the loan purpose, and you can use that. You can use the same scenario. Imagine now, if I want to buy 13 lakh rupees house in Bangalore, and like I can pay in maximum FD of 8,000 rupees with the rate of interest suppose 9%. And so under this situation, when you work on, when you have certain goal or certain dream to work, so you can use goal seek command. So I just wrote some, the price of house is some X. Then what we do, when we wrote the calculation of how we can work on PMT or maybe goal seek, those things are very important. Understanding of those things are very important, those very crucial. And so I hope you understood what we did in this session. Very simple concept of goal seek implementation, one way, two way data table, loan amortization schedule, how we can work on loan amortization schedule. Because normally the debt instrument can be amortizing debt instrument, can be non-amortizing debt instrument. So probably the loan, car loan, bike loan, whatever we are talking, these all are amortizing a debt instrument. And an amortizing debt instrument basically mean, in this case of debt instrument, you we instead of just paying the interest, we pay some part of the interest and beyond the interest, so that the value become zero. And that is something important which you need to work on. And so probably we pay EMI which is more than the interest. And by paying EMI which is more than the interest, what you actually do, every moment, you try to reduce the value of principal, and ultimately at the last moment the value of principal becomes zero. So that is something which we need to understand here. And ultimately, if you see the remaining principal in this case is zero. So I hope you understood the case of working on a financial, and this is the first session on the financial modeling, where I basically discussed about the time value of money, and also I've talked about the implication of financial planning, how you can work on. Thank you for listening. Take care.